Let's go over a couple of examples. Which one is linear? Well, the very first one is 1 minus y times the first derivative of y plus 2y equals to e to the x. Well, is this a linear differential equation? Let's compare this differential equation with the general definition of linear ODE. We know that each of the expressions multiplied by the derivatives must be in terms of x. So as you can see here, you have expression in terms of x, expression in terms of x, and so on. And finally, we have a function in x. So let us take a look at this example here. In this example, the expression multiplied by y prime is not in terms of x, it's in terms of y. So this is our red flag. So because of 1 minus y, it is not linear. Let's take a look at second example. In the second example, we have the second derivative of y plus sine of y equal to 0. There we go. Okay, the expression multiplied by second derivative is 1 plus, well, here we have a function in y. Note that all functions must be in terms of x. So this is the red flag that we have here. This causes the ordinary differential equation not to be linear. So because of sine of y, it is not linear. Okay, another example for you. Example number 3 says, well, here you have the fourth derivative of y plus y squared equal to 0. As we know, the function must be in terms of x, not y. So, as you can see, y squared makes this differential equation not to be linear. So because of y squared, it is not linear. Another example for you. Here we have 1 minus x times the second derivative of y minus 4x y prime plus 5y equals to, the function is cosine of x. Okay, well, let's see what we have here. We have the derivative of y and we have an expression in terms of x. So far, so good. We have y prime and we have an expression in terms of x next to it. So far, so good. And then here you have the constant 5 multiplied by y, which is absolutely fine. And on the other side, you have cosine of x, a function of x. So as you can see, this ordinary differential equation is linear. This is a linear ODE. And now Number 5, the last example here says we have x times the third derivative of y minus the first derivative of y raised to the fourth plus y equal to 0. Okay, let's see what do we have here. We have the derivative of y multiplied by an expression in terms of x. We are fine with the first part. However, here you have the derivative of y, which is raised to the fourth power. This is the red flag that we have here. So because of this exponent 4, this differential equation is not linear. So because of the fourth exponent, it is not linear. Very well. In this example, we're interested in analyzing an ordinary differential equation. What is the order and if it's linear or not? Determine the order dependent and independent variables and also if the differential equation is linear or not. The very first one is, well, here we have the third derivative of y minus 5x times y prime equals to e to the x plus 1. Well, as usual, here we have the derivative of y. The expression next to it, which is invisible, is just 1. Minus 5x, y prime. Well, here we have the derivative of y, and here we got negative 5x, which is an expression in x. So everything looks good. And here on this side, we have a function e to the x plus 1. What is the order? The order is 3. The highest order of the derivative appears in the equation. Well, this is function y in terms of x. So y is dependent, or this is your function, and x is independent. Also, it is a linear ordinary differential equation. Next example, number 2. Here we have t times the second derivative of y plus t squared, the first derivative of y, minus sine t, trig function sine, times square root of y equals to t squared minus t plus 1. Very well. So instead of having x, we have t as free variable. T multiplied by the second derivative of y. T squared multiplied by first derivative of y. Here you have sine t times square root of y. The square root of y is red flag. It means that we don't have linearity here. So because of square root of y, we don't have linearity. Well, what is the order of this differential equation? The highest derivative is 2, so order is 2. As you can see, y depends on t. Y is dependent and t is independent. And this is not linear because of square root of y. Number 3, we have s squared times the second derivative of t with respect to s plus s times t times the derivative of t with respect to s, which is equal to s itself. Very well. So what do we have? We have s squared times the second derivative of t. We're good here. But here we have t times the derivative of t. This is the red flag that caused the differential equation not be linear. But what is the order? Order is 2. Independent variable is s, free variable is s, and t depends on s. T is dependent, and s is free or independent. So as you can see, it's not linear because you have t times the derivative of t. Not linear because of t times dt over ds. Well,